This video is brought to you by determination, and for this chapter I hope you have a lot of it. Here's one of the quotes from one of your slides. It says, if you want to get somewhere, you have to know where you want to go and how to get there, then never ever give up. Never, never give up. Today's chapter unit is 10-1, areas of parallelograms and triangles. You're going to need about a third of the page for each of our sections, and you will need 2 markers. At the top of your paper, I want you to make 2 boxes. One that says area of a parallelogram and area of a triangle. And then only in that first section, I'd also like you to pause the video and please draw these 7 figures. Inside the area of a parallelogram box, we're going to actually write the area of a parallelogram, which, as you remember from 7th grade, is base times height. And we abbreviate that to b times h. So lowercase b stands for the base of the shape and h the height. For a triangle, the area is the base times the height, but cut in half. And when we abbreviate that, that's b times h divided by 2. The bigger question I think that we have, though, and I'm going to move the puppy to the side here, is how do you find the base and the height? Where is it? So this is where you're going to need your 2 markers. I'm going to go ahead and say that the height for me is going to represent the color red, and that blue is going to represent the base. What I need you to know is that first we always find the height. And the important thing that we should know about the height, also known as the altitude, is that it must always hit at a 90-degree angle. That means the line that it's perpendicular to would be the base. So this is the relationship we're looking for in all of these shapes. Now for this first one, I'm going to look at this parallelogram. This is a rectangle. I'm going to look for any line that makes a right angle. And I have some choices here. I could choose any of these 4. I'm going to choose this side right here. If I choose that as my height or my altitude, then I'm going to choose this as my base. Now clearly I could have chosen this as my base also because it makes a right angle there as well. But that means these are the 2 values I would use to find the area of the base and the height. Next I want to look at this triangle. Now even though the formula is different, we still need to find the base and the height to use the formula to find the area. So I'm going to look for a line that makes a right angle, and that would be this one right here. If that's my height, then this is my base. For my next shape, I'm going to choose this as my height, and this is my base. For my square all the way over in the corner, like the rectangle, I have a lot of choices, but I'm going to choose these ones again. And now I want you to look at these 3 shapes. For these 3 shapes, we have some kind of weird things going on. So let's start out with first this one over here. Clearly this is the height. Clearly this is the height. Clearly this is the height. The question is, for these 3 shapes, what's the base? Is the base this entire line or just the base of the shape, just the piece that actually touches the ground? This dash part does not exist. Well, the answer is it's only this piece. It's only this piece that we would call the base. It would only be this piece. So what I want you to remember, and you might even want to write it down, is that if the altitude is on the outside of the shape, whether it be a parallelogram or a triangle, the base has to be only the portion that belongs to the shape. The invisible part is not included in that value. For the second section of your notes, I'd like you to copy these 2 examples down. And even though we're going to focus on this one first, once you've copied them down, I'm actually going to cover this one up so we can focus on just this one on the left. Oops, just this one on the left. So the first thing I need to do is figure out what this shape is. And I'm going to ask myself, is this a parallelogram or is it a triangle? Well, clearly this is a parallelogram, so I'm going to be using the formula area equals base times height. So I'm going to need to find the area by finding values for the base and the height. I'm going to look for the height first, and I'm going to look for a line that makes a right angle. and I found it right there with my 4 inches. Then I'm going to look for the line that it's perpendicular to, and that will represent the base. And the base in this case is 5 inches. I'm going to take those values and I multiply them. That means that the area of this parallelogram is 20 inches squared. It's inches squared because inches times inches is inches squared. And that's it. For our second shape, when I look at it, I have to ask myself, is it a parallelogram or a triangle? It has 3 sides, so it must be a triangle. My formula for the area of a triangle is area equals base times height, but this time cut in half. I'm going to use those same color codings. I know my height will be red, and again it's going to make a right angle, so it's right here. I know that I'm going to be plugging in 146 inches for the value of the height. I know that the base is perpendicular to the height, so that looks like it's 160 inches. Now I'm going to take those 2 values, multiply them, and then I'm going to cut them in half. Now 160 times 146, I'll spare you the calculations, but if you were going to multiply it, it would look something like this. And you would get a bunch of values. Once you multiply them, you get 23,360 divided by 2. I'm going to shrink this down just a little bit so we can fit this in. And when we divide that in half, inches squared, and when we divide that in half, we get 11,680 inches squared. That's how many square inches fit inside of this triangle. And that's how you find the area of a parallelogram or a triangle. This last question will go in the very last section of your notes, and I want you to notice the directions say find the value of h. Now, I'm going to tell you this hint. This is actually from your homework, and it's question number 11. So inside your homework, this is question number 11, so I'm doing one of your homework questions right now. Now, the first thing I'm going to do is I'm actually going to move this picture over here, and we're going to save this guy over here by my squirrel. Actually, I'll hide it under here so you don't look at it. And I'll put in the values so you can see what it looks like in your homework. There's an 8 here, a 10, a 14 right here, and an H. The H represents this line here, and the 14 is this line right here. Now, the reason why I drew this twice is because I wanted to show you what this looks like. So here's the values right now, and I wanted to show you what that H is. Oh, excuse me, let me move this over. Here we go. If I rotate this like this. So again, here's the picture they gave you, and I'm rotating it counterclockwise right next to it. And I literally do want you to have both these pictures next to each other. So I'm going to relabel it. This is the H, this is the number 8, this is a 10 right over here, and the 14 is really close to the O. It's right here. Here's the 14 right there. You see it? Now, in order to find the height here, I have to kind of recognize that there are 2 things going on here. I'm going to call this figure 1, and we'll call this figure 2. In figure 1, if I want to look for the height, I kind of prefer this as my height, and I prefer this as my base. But in figure 2, I prefer this as my height, and this as my base. The truth is that in a parallelogram, when you rotate the shape, you can find the area using 2 different values, especially in cases like this where the height is on the outside, can be constructed on the outside. That means I could find the area twice. So I'm going to start off with this first one. For my first figure, I know I'm going to be using area equals the base times the height. And we've already said that the area has a base of 14. I got that from this value right here. If that's 14, this must be 14, times the height, which we identified as 8. So I'm going to do my calculations. 14 times 8, that's 32. 8 times 1 is 8 plus 3 is 11. That means the area is 112. And since, notice they didn't give us any units, we can just call this units squared. So here's what I know. And forgive me because I'm going to mess up your picture here, but it means that this purple area right here, that's my dog, is 112 units squared. And you know what? That's the same amount that this shape fills in. All I did is rotate it. I haven't changed the area, so the area should be the same. So let's see what happens. I'm going to use this information. I think I'm going to have to move my squirrel up here. That is a one determined squirrel. Okay, so this is still a parallelogram, just rotated. And again, I'm going to multiply the base times the height. In this case, the height is unknown. And the base would be, well, here's the base, but down here it would be 10. Okay, so I'm going to multiply those two, and there's the area. Oops, sorry, area. So area equals 10 times h. Well, because I did the calculation over here, I know that the area is 112 units. See that? Now this is just a simple calculation right now. Notice that on this side I was solving for a, and over here I'm solving for h. So I need to remove this 10 here. They're multiplying by 10. So I'm going to divide by 10 on both sides. And that gives me my value, my hidden h. The other height is 11.2 units. So I use the area to find one of those. These two questions are really great questions, so please make sure you're really taking a look at your homework. And I absolutely want to make sure that you're doing number 12 and 13. And please recopy this homework assignment from your notes.